Good morning. As part of Braskem digital transformation strategy, I will present a project called the Virtual Online Analyzers. My name is Gustavo Neumann. I have been working in Braskem Automation Group in the last 20 years and 3 days. And I have worked during 11 years as automation engineer, 7 years as automation coordinator, and the last 2 years I'm SME in the automation group, and I'm playing with data, with models and simulations. Braskem is today the largest producer of thermoplastic resins in the Americas, and the largest producer of polypropylene in the United States. We have 41 industrial plants, 29 in Brazil, 6 in US, 4 in Mexico, and 2 plants in Germany. We have clients in around 100 countries. And we have more than 7,500 employees, team members around the world. And other numbers, financial numbers, are showed there. The partner company of this project is Radix. Radix is a digital engineering company, and Tarek will be the panelist, can talk more about the Radix after this presentation. In the polymer plants, we have a lot of properties to understand how the polymer will behave during the processing in the third generation plants. So we need to keep these properties in some levels and between ranges. The Braskem production has some of these properties measured in the laboratory. We have 2 different traditional approaches. One is send the samples of the process to a laboratory to do the analysis, but we have a large personal costs. We have a delay between the collection, the sample from the plant, and see the value online in the PIMS, Process Information Management System, and more than 2 hours to have these measurements available, and more time to operator do some changes in the process to keep at the set points. Other option is physical devices to measure these properties online, but is expensive and not easy to install. You need many hours to invest in calibration because is a current problem of this type of equipment. Our approach is develop some virtual online analyzers using machine learning models to provide these measurements, this information in real time. And having this information available, it's possible to make a faster decision and good control. So you can use this virtual analyzer, including in advanced process control applications. We have some examples of this. And close the loop using this type of application. In order to accomplish this goal, the analyzers needs to have connectivity, have access to the process data, reliability, of course, because we will control the plant and certify the product using this information of the machine learning models, and availability to make the results available to other plant solutions, as the example of advanced process control. We developed this in a virtualized server inside the industrial network. And these VOAs, virtual online analyzers applications, read the information from the automation control systems as or using OPC protocol, read this information from the distributed control system, DCS, and write after using this data to classify the information using a classification model and a prediction model to calculate the information. So we write this information in DCS. We have a interesting convergence between IT, OT, and ET, because we use these machine learning models and AI to produce these results, combined with first principle models, because we input some process knowledge in the models. So we have a hybrid model with statistic and phenomenological. Use the communication standards, as I said, OPC. And we have some developments considering remote access as a deployment and connectivity to other services. Our project was conducted in 12 polymer plants for polypropylene and polyethylene in the south of Brazil, extremely south, in the Triunfo, the city. We consider different technologies of polymerization, as you can see in the right. We developed 57 new virtual analyzers, and this set of virtual analyzers is formed by 47 classification models and more than almost 150 regression models. These virtual analyzers are responsible for just 4 different analyses of properties. Is the main information for polypropylene and polyethylene. The workflow, we started with engineering assessment, combining information from the process engineers, SMEs, operators, IT and OT teams. After this, we define which data we need to collect from the plant and do this extraction. Use this data using some cleaning, transformation steps before start the modeling. After this, we train the models, the machine learning models, and test during the same steps. And after this, we implemented online and do the validation of these models. If necessary, we go to first steps just to correct, refine these models. The models were, as I said, was implemented in a server, right in the PIMS system in DCS, and we have a lot of HMIs, human-machine interfaces, to see the performance of these models and to support the operator in the decisions. So we have some Power BI interfaces, DCS interfaces, a lot of different types of dashboards, depending on the application that we need to how to use these models. As I said, we have a multidisciplinary team. In the beginning of the project, we organized a workshop and with the stakeholders and the project team. Almost 100 people discuss the project, discuss the scope, and refine how to conduct the project during this. During some months, our first challenge was we had just 8 months to develop these 57 models. And our traditional approach, we developed 1 model in 9 months, almost a gestation. Yeah? So this was our first challenge, and for this reason, we talked with Radix to support us in this development. After this workshop, we put all the stakeholders together and have a high level of involvement. This is one major point to success of the project, because we have these stakeholders involved since the beginning of the project. This is just one example. The black points are the laboratory analysis, and the blue lines are the specification, the limits of this measurement, and the yellow or green line is the virtual analyzer. So you can see a good response between the points, and you can see you have information between two different lab analyses. So we can make decisions before the information of laboratory is available. This is an example of our first online test. In this test, the operator didn't see the laboratory values, but laboratory continued making the analysis, and we could see the information, but the operator not. The decision was made just with the virtual analyzer. The results of this project, we can use these virtual analyzers to have agility in the decision, improvement in the process, because we can reduce the variability of the properties, increase the quality of the product, reduction of specification production between transitions. For example, we have a fast transition between different products, possibility to change the routine and the frequency of the laboratory analysis. And this is just a feedback of one operator in the test that I showed. Some lessons learned, compiled. We started this project before Braskem created the digital center. So we started with the traditional approach of the development of a project. And during the project, we defined that we need the agile methodology, because, as I said, the challenge was the time of development. So this agile methodology help us to have more velocity. The one other lesson was the architecture and infrastructure in the industrial network, because we defined it to implement not on a cloud, because the information is used to process control. So in our opinion, we needed some robustness and some cybersecurity issues. For this reason, we started the development in the network, industrial network. But we have another example here in the United States that the development is in a cloud platform. So we are discussing which approach is better considering these issues of robustness and cybersecurity. We have the continuous improvement of the codes, combining some packages available online in the Python for the Python services, and develop some scripts internally together with Radix. We use machine learning methods combined with phenomenological models, as I said, to obtain high performance models, high accuracy. As I commented, the involvement of the operation since the beginning was important. We define focal points for each plant from the operator to be the the guide to get the informations from the plant and put in the model together with machine learning, together with the statistic. This involvement was important because the operator, since as part of the project since the beginning, is as the operator is the final user, then this was an important issue for the success. During the project, we trained all the stakeholders with new methodologies, with machine learning issues, very transparent to show, to understand, to people understand what we are doing. It's not a black box, it's a model. What is a model? How to use this information? So we had a lot of training during the project. As I said, this project was part of our digital transformation strategy. 2 years ago, our CEO encouraged all the teams from Braskem to develop a digital transformation initiative. So we have an engagement of high-level leadership since the beginning of this project. And the next steps is a continuous integration of all the systems, all the parts, and use the information to make a better process control. So, thank you. And if you want more information, you can talk more about this. Thank you.